Hello, today we are going to see a decently lengthy question and how can we practice or how can we build up our approach such that we are able to solve the question fast. So the question is in front of you. It's one of the starting questions of time, speed, distance. It does not involve anything except the relations between time, speed and distance. So a man covers a certain distance at a certain speed. So it's a scenario is changing. If he had traveled 6 kilometers faster, he goes fast enough, he would reach 30 minutes earlier. Obviously, he will take less time. But if he had traveled 9 kilometers slower, then he would have reached 90 minutes later. Find the distance. A commonplace question, it does keep popping up in exams because, as I said, it's a decently lengthy question, right? So I'd ask you, you'll not appreciate the faster approach that I'm going to talk unless you do not know how lengthy is the traditional solution, right? So pause the video, write the equations, time yourself, see how much time you take to solve the equations, and then we will see if we can do a better job. First, a commercial message, not more than a minute. CAT 21 batch announcing the start of a third CAT 21 batch. The batch would have recorded concept videos which you can pause, watch at your own speed, fasten it, revise it over and over again. Plus, there would be live online classes. So the live online classes would be that of doubts and revision. Revision is very important, students. So whatever you learn over here, that would be very quickly revised on a Monday, Wednesday, Friday, 7 to 8 p.m. You'll have a regular schedule what you have to watch and what we will be revising. And on Saturdays, we will be doing problem solving, tackling good quality problems, right? The batch start, the timings are here and the batch start date is 1st of March, Monday. So the timing is well thought out. I don't want to, crowd out your practice time. So I've kept a time such that most of the people don't study at this time. So we'll revise it. It will only add to your study time, right? And then your whole evening is free to practice more. Self-study is very, very important, right? I guess that should be a minute. So let's get back to our agenda. Hopefully you would have solved the question, because if you have not, then you will not realize how lengthy the solution is and you will not appreciate the efforts needed to reduce the work, students, right? So a traditional question, nothing twisted, covers a certain distance at a certain speed. If I traveled 6 kilometers faster, I would reach 30 minutes earlier. So speed and time are given, and most of the questions, two things will be given, as in they may not be numeric values, like it's not 6 kilometers, it is 6 kilometers per hour faster, but then I can use variables, right? X and X plus 6. It's not 30 minutes earlier, but then I can use T and T minus 30. And the moment I know speed and time, my mind starts racing. I will obviously have to deduce the third one, that is distance, that is speed into time. Oh, so keep in mind I'll need to multiply them, right? So I'll write it that way itself, students, right? So my first scenario given is that my speed is X plus 6 in kilometers per hour. Okay, and my time is that I reach 30 minutes earlier, so I'll be taking lesser time. And while writing it also, you should keep in mind that the units are different here, right? So if I'm just multiplying these and I want to find a value, then that would be an issue. But then there is a second scenario here, part 2, and here it is 9 kilometers slower, so this is X minus 9. 90 minutes later, more time taken, T plus 90. And now what am I doing is finding the third thing. Speed into time is distance. So I multiply this becomes my distance. Here also I multiply it and it becomes my distance. And what do I do with part 1, part 2? The distance, think in terms of distance, the distance is same. Right, so that is how my equation forms. And once I form that equation, that also takes away another worry of mine. What? That of units. Because I'm not finding this independent numeric value, I am equating this to something else. So, and if I'm balancing two sides, as long as I am consistent, this is also kilometers per this. This is in minutes, I know, but this is also in minutes. So long as both sides are represented in the same, are consistent in the units, it doesn't matter if they're incompatible with each other. So what I'm saying is, don't look at half, don't look at 3 by 2, 90 by 60. It will only make your calculations worse off. Just think of the entire, even t is in minutes. So 30 is in minutes, this is in minutes. So what I'll do is I'll just divide this by 60 to make it hours. That same thing I'll do here, and the 60 is going to cancel out at the first step. Right? So I can go ahead and proceed it this way. The second hurdle is, if you open out these brackets, you are left with only one equation in x and t. Now that's a big hurdle, and a lot of students get stuck over that till the time you realize that there is an original situation here, student. And what is that original situation? I travel, this 6 is added to some, so there was some speed that I had. And when I had a speed of x, that is the time I was taking time t. Right? So when I go 6 kilometers faster than some speed, I would take 30 minutes less than the time taken earlier, that is at x. So at x I was taking a time t, so x into t is also the distance, and now I have a relation of the type A is equal to B is equal to C, and such a relation is let's say are two equations, two independent equations. Either take A is equal to B and B is C, or A is B, A is C, or whichever. Take any two pair, there are two equations. So here you get two equations. Yeah. Finally, now we are solving the equations. The better way to solve the equations are, take the first and the second, and when you open out xt, xt is the first thing that cancels, so I'm not writing that. Now this x gets multiplied with a minus 30, so I'm writing it here, students, right? So I get a minus 30x with the sign. The 6 gets multiplied with a t, so I get a 6t, and the product of constants is plus minus, so that's a minus 6 into 30. I'll take it to the other side, right, which will become plus 6 into 30. The plus sign, right? So that is the equation. Now the second equation, rather than using these two, you can do it. I would use the first and the third. So the first, because the first is very easy, xt. So the same thing, xt cancels out. X multiplies with a 90 plus 90x. 9 multiplies with this 90, and the constant here is a minus 9 into 90, goes to the other side, becomes a plus 9 into 90. Now I can say, oh, now I am nearing the end. Now I see a simultaneous equation, and I just need to solve it, and I'll get my x and my t. Yes, but the idea is we have already written so much of pencil work, and it is only after a lot of efforts we have reached this simultaneous equation. So how do you reduce this work? And remember, this is not a video on some concept or some intelligent work. This is a video about how you should practice. How when you see a question, you should not just solve it and go ahead. You should see, I have spent so much time. How do I reduce that time? When I used to prepare 2 decades back, that time there was no so much of help available. So I would figure out my own ways. Oh, this number goes from this denominator over here, that goes from here to here, and I would imagine all that, and I would try to write a couple of line steps later, right, in one line. So can I write these equations directly? That is the crux of this session, students, right? Yes. So you know that there is speed, and you know that there is time. Okay, and you know that speed increases by 6, so the 6 is in a bracket with s. Just imagine it, don't write everything. And this time reduces by 30. This 30 is in a bracket of t. So this s will get multiplied with the other one. Remember this way. So can I write that directly? Yes, I'm writing it. Minus 30x. This 6 gets multiplied with this plus 6t, and the constants get multiplied with each other. That is a minus 6 into 30. Take it to the other side, becomes plus. Can I do this? Absolutely. In one go, yes. The second one I'm writing, that too without even this, can I write? Oh, I should not have erased that, but let's see. 9 kilometers slower minus 9 gets multiplied with t, variable t. Okay. Oh, so that is a minus 9t. 90 minutes later plus 90 is in the bracket of t, which gets multiplied with x. Oh, so plus 90x. And what happens? The constant is product of these two. Minus plus 90 minus 9 goes to the other side, 9 into 90. I'll be giving you another question and you should be able to write this like this, and then you should see how much time you have saved. Anyway, now we just have to solve it. So this is easier to eliminate. You just need to make this 90 into 3 and you can add it because they will plus minus will cancel. 3 times 18 and minus 9 is a 90 multiplied by 3. This is easier. 90 90 add 9 and 6, 15 into 90. 9 cancels with a 10, so I get t is 150, and remember this is in minutes, and t is 150. Substitute it back in any of them, you'll get your speed x also. So I will substitute it where? In the second one, and I'm cancelling this 9. Okay, this 9 is not there, it is just a 1. Okay, this 9 is not there. So this is a minus 150 plus 150, 90 plus 150 is 240 and 10. So x is 24 kilometers per hour. Right? You have your x and a t. So from here I'll find my distance, and now since I'm finding a distance, now remember I'm not equating it somewhere, so I can't find this numeric value because this is in minutes. So obviously I'll do this way. Anyways, you should know this. This is 2.5 hours in your mind, not so much of pencil work, right? 2.5 hours. So 24 and 24, 48 and another 12, 60 kilometers is the distance. So I don't know if you have picked the shorter way, but let's see. There's some more value in this session, students. So continue paying attention very quickly. Yeah, there's some very nice insight which is very lesser known. So there's some good incentive for you to hang on. Okay, first let us practice what we have learned. What if the data goes 5 kilometers faster, I would reach 10 minutes earlier. Goes 5 kilometers slower, I would reach 15 minutes later. Find the distance. Now time yourself and see, can you do it fast? 5 kilometer faster plus 5, but into time, I would reach 10 minutes earlier. 10 minutes less, but into speed, is equal to 5 into 10, 50. 5 kilometers slower minus 5 into the other bracket, oh, that has t in it. 15 minutes more plus 15 into the earlier variable x is 5 into 15, 75. Have I got this? So fast, reduce it. Oh, plus 5 minus 5, just add it up. 5x is equal to 125. X is 25 kilometers per hour. Substitute it. You can reduce or directly substitute. I'll put it here. 250, 300, 300 by 5. T is equal to 60 minutes. Okay, right? So that's 1 hour. So the distance is 25 kilometers. So fast, so easy. Right? So does it work? It works fabulously well, students. I would say don't waste your time following tough question. CAT is not about tough question. CAT is about very regular questions or so on. How can you manage it faster, right? And standard questions like this are so common in SNAP, NMAT and so on, and all of those tests are a question of how quickly can you do things. So I think you should spend a lot of time here. Okay, and the gem that I had promised you, the part that is hardly known. Student, these are very specific values. Okay, these are very specific values. So what are those specific values? The speed s, pay attention carefully, the speed s in one case is going to s plus 5. Oh, I should use an x only. Yeah, it's easier. X plus 5. And in another situation is going to an x minus 5. Or rather, let me write it below just. So this x is once becoming an x plus 5 and is once becoming an x minus 5. And the specific part is this part. They both are same. Okay. And here, because they are same, because they are same, I'm not writing it. Yeah, hence the speeds will be in the ratio of the other two numeric values. So these two quantities, these two boxes will be in the ratio of 10:15. This is less, that is more. Think a little logically, right? This will be in the ratio of that other values, because only because these are the same values. Student, what I'm telling you is not based on proportionality. It is based upon how solving equations in a better way. So it's just that I have done a lot of back work and saying that those equations, if they had a plus 5t and a minus 5t, they cancel out, then that question becomes as easy as this. And now tell me, do you know that the difference between the speeds, this is nothing but 2:3. Do you know that the difference between these two is 10? One is minus 5, one is plus 5. So make the difference 10. So this speed is 20 kilometers per hour. This speed is 30 kilometers per hour. And got it? And if you want the original speed, 20 is after subtracting 5. So this is 25 kilometers per hour. No equations, nothing. You can do all of this in your mind. And you know, a fun element here is, oh, the time. Pay attention to this, the time. Okay, here the time is fast. I'm going slower, I'll take 10 minutes more. Slower, I'll take 15 minutes more. In fact, don't even think which is which. Just let's go ahead with this order only. Time 10 minutes earlier, t minus 10. Time 15 minutes more, t plus 15. Okay, do you know the interesting thing here? These two are also in the ratio 2:3. Which is 2, which is 3? The smaller one will be 2, the bigger one will be 3. Same thoughts. Do you know what's the difference between them? You know, these are things we should know. There's a reference point. There is something gone 10 less. There's something gone 15 more. So if I talk about this and this, what is it? You know that the difference is 25. So two numbers in the ratio 2:3, difference is 25. Your most simplest ratio question. One is 25, 25 twos are 50 minutes. 25 threes are 75 minutes. Right? And you want the original time. Oh, this is after 10-minute reduction. So this is 60 minutes. Now you have all three speed, original time. Lower speed will get clubbed with which one? Higher time. Okay. Higher speed will get clubbed with lower time, and this will get clubbed with this. These all are your distance. Your distance could be anything. 25 into 60 minutes. 60 minutes is 1 hour. So the answer here is 25. Oh, we had found that answer earlier, right? So I was wondering. Or you could use this lower one also. 20 into more time, 75. I'm just doing this for your comfort area because I can be, check, are they same? 3, 25, right? And the same thing will also be higher speed 30 into lower time, 50 by 60. Check, is this also 25? Perfect, right? Simple enough, straight, right? Okay. And just to make you practice one more here, students, I'm changing the value for the last time here. Pay attention, a little different, students. Yeah, little different. Find the distance. Let's see. If I travel, I forgot the values. I'll just say, had I gone 3 kilometers faster, I would have been 40 minutes earlier. If I traveled 2 kilometers per hour slower, I would have reached 40 minutes later. You can try the original way, writing the equations and doing, but is there something specific? This time the increase decrease is not same in speed. But do you know that the increase decrease is same in the time? This is 40 minutes, this is 40 minutes. So the same fundas get used here. So pay attention, the speed, there is some original speed that becomes s plus 3, that becomes s minus 2. There is some original time, that time becomes minus 40 in one case, in the other case becomes t plus 40. And because last time saying don't use this anywhere and everywhere, there is no strong conceptual backing to it. It is only fast working. Because this is a plus 40 and a minus 40, these two ratios, this as well as this, will be in the ratio of the other two numeric values. Will be in the ratio 3:2. And now use common sense. So this is bigger, so this will be 3:2. Do you know the difference is 5? Oh, so the two values and I want the difference 5. One is 5, 5 times. 5 3s are 15. So this speed is 15 kilometers per hour. You don't need to find the other ones. Yeah, I'll directly go just find one of them. Oh, this is more speed. Oh, these time are also in the ratio 3:2. Which is 3:2? Oh, this is 2 parts. This is 3 parts. Okay, and what is the difference here? The difference here is 80. Minus 40 plus 40. 80 difference. Oh, 1 part 2k, 3k. K is 80. 80 into 2, 160 minutes. 80 into 3, 240 minutes. Okay, so this time is 160 minutes. 240 minutes. I found both. Now, what is this? Higher speed, lower time. This is not a nice time. I like this time. This is why 4 hours. Okay, so let's go here now very quickly. 3 parts is 15, 2 parts is 10. Yeah, 10 kilometers per hour for 40 hours. The distance is 40 kilometers. Done, students. Over. You want to do it with other values? Let's see. Let's do this also. 15 kilometers per hour into 160 minutes by 60, 15 4s are 440 again. Let's go to original speed. 15 was after an increase of 3. This is 12 kilometers per hour. This is after, this is 200 minutes. So speed into time, but then this has to be by 60. 12 5s are 540. Yeah, obviously this is just a check. All the 3 distances has to be equal, right? Okay, so that is how you handle this lengthy question. How do you solve it faster?